Okay, number 2 says, is 1 and 2/5 a mixed number? Yes, it is. Because it has a whole number. It has the whole number. What's the whole number, Caleb, in this problem? 1. And I'm going to make it look like a number 1. And a fraction part, which is 2/5. Okay? To decompose means to break it apart. 1 and 2/5 is the same thing as 1 plus 2/5. I just don't draw the plus sign in between there because I'm in a hurry. It's also the same thing as, what is 1 whole worth, Hadley? It's also the same thing as 5/5 plus 2/5. It's also the same thing as, remember, I have this addition right here, so the denominators have to match. They do, and I never change the denominator when I'm adding or subtracting. 5 plus 2 is 7. Okay, turn the page. Let's practice. Muhammad measures water with 1 1/4 measuring cup. He fills the cup 7 times and pours each 1/4 of a cup of water into a bowl. How much water does Muhammad pour into a bowl? Okay, well, I'm not going to keep drawing the models, but I will one more time because we don't have time for this. But I want to make sure we all understand what it's asking. So I'm going to go ahead and draw 7 models. 5, 6, 7. Okay, and so each of these are, one model is equal to 4 parts with the denominator 4. And he says that he fills it up only 1/4 of the way. So I'm going to fill up my model only 1/4. And they call it 1/4 because for every dollar bill in US money, it has 4 25-cent pieces. So we call this a quarter. Okay? All right, let's keep going. All right, so now let's add those together. I'm going to count 1, 2, 3, 4, 5, 6, 7 over the denominator of 4. And let's break that down. So I have 1/4 plus 1/4 plus 1/4. The denominator when I'm adding, does that ever change? No, I may leave my denominator alone. I add up the top numerator. 1, 2, 3, 4, 5, 6, 7. 7/4. Okay? So the answer would be that he uses 7/4 cups of water. Okay? All right. That looks great. Now, because we're going to move on to the converting a mixed number or an improper fraction into a mixed number, let's practice. So I know that this is the answer. But it's improper because it went past the whole of 1 on a number line. And once it goes past there and the denominator doesn't change, it turns into an improper fraction. So let me draw that. I started at 0. I have 1 whole, and I have 2, and 1 whole, Hadley said, was 4/4. And we sliced these into 4s. Let's count to make sure I have 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, I made my model. And I am going to start here with 1. And so for this little guy right here, I start there. 1. This guy's represented there. 2, 3, 4, 5, 6, 7. Did you see that I just hopped past 1 hole right here? 1 hole. And that's when I go past, I turned it into 7 for the numerator. Let's convert it back. I can see using my eyeballs that I went past 1, so I know it's 1. And I can see that there's this 2, 3 in the numerator, and the denominator is still 4. So 7/4 is equivalent, I'll do it right here, 7/4 is the exact same thing as 1 3/4. Okay? All right, remember before we left for the weekend, we practiced jelly beaning. Jelly bean. 1 times 4 is 4. Jelly bean. 4 plus 3 is 7, and my denominator doesn't change, 7/4. Okay? All right, let's move on to 4. I had all that space I could have written down there. I don't want to check my answer because it's all up here.